Newton's laws explained by football. Football. I chose football because flag football is a sport that I like to play, and I think it'd be cool to figure out how Newton's laws apply to the game. The average weight of a football is 15 ounces. The average speed the football moves is 96.5 kilometers an hour. The football moves after it is either thrown or handed off by the quarterback. Some of the basic rules of football is that there are 15-minute quarters. Getting the ball all the way across the field gives you 6 points or a touchdown. An extra point is after each touchdown. It can be for 1 or 2 points. You can kick a field goal in between 2 posts for 3 points. You have 3 or 4 chances to get 10 yards, and there is a first down every 10 yards. The game is also played on an 100 by 55.3 yard field. The history of football is hard to understand because football was being played in many places, but the first organized game of football recorded was in 1869 in New Brunswick, New Jersey. Now, time to find somebody who can help us show Newton's laws. You? Yes. Yes, come in. Yes. Alright, let's get started. Okay, so you're probably a little bit confused how that relates to Newton's laws, so let's run it back. But first, let's go over Newton's laws. Newton's first law states that an object in motion will stay in motion, and an object at rest will stay at rest until acted upon by an external force. Newton's second law states that the acceleration of an object equals the net force on the object divided by the object's mass, or A equals F divided by M. Newton's third law states that when you apply a force to something, it applies an equal force back in the opposite direction. Now, let's look for those in the video. The ball staying still on the ground represents Newton's first law because the ball is at rest until the center snaps the ball to the QB. Right here is an example of Newton's third law, but first let's get a close-up. As you can see in the slow-mo, when pushing down on the ground pushes back up at you, making you go upwards. Me throwing the ball is an example of gravity, a field force. Gravity is pulling the ball down so it doesn't just stay up in the air. Here, you can see the second part of Newton's first law. You can see that after I missed the catch, the ball is on the ground staying still. But let's say I did catch the ball. Here's probably what would happen. Here, in this terrible form celebration, you can see that when I push off the ground pushes me back upwards. This is an example of Newton's third law. Now, let's focus on another part of the game. When an offensive lineman pushes off a defensive lineman, they are both pushing force in opposite directions. In the crazy occurrence that both linemen are pushing at the same force, there would be a net force of 0. Usually though, if one side pushes harder, there would be a higher net force on one side. Now, as you can see in this video, both running backs are applying the same force going forward as the other, but one of them weighs more. The heavier running back will go slower. This is an example of Newton's second law. Now, there's going to be another example of Newton's second law. As you can see in the first clip, I put less force into the ball, but in the second clip, I put more force into the ball, which means it accelerates more and goes farther. Now for this next part, let's get cartoony. As you can see in the video, the running back runs a curved route. As you can see here, the total distance he traveled was 20 yards, but his displacement would be 15 yards. This is because your displacement is the straight line distance between your initial and ending point. When you measure distance, it is only the magnitude quantity. But when you measure displacement, it is magnitude and direction. But let's say the running back did run in a straight line. In that case, his displacement and distance would be the same. But if the running back somehow makes it back to the line of scrimmage, his displacement would be 0. This is because there would be no difference between his initial and ending point. And one last thanks to my cousin Andy for tackling me for the video.